Hello everyone, myself Sujit Singh welcomes you all. Before starting with different topics from chapters of class 9th mathematics, let's discuss the weightage given to different units of the same class. So here I have drawn a chart where the number of units are suggested with their respective marks. Like the first unit number system containing chapter number 1 only carries 6 marks. Second one is algebra containing chapter number 2 and 4 carries 20 marks. Third is coordinate geometry containing chapter number 3 only carries 6 marks. Fourth is geometry containing chapter number 5, 6, 7, 8, 9, 10 and 11 carries 22 marks. Fifth one is mensuration containing chapter number 12 and 13 carries 14 marks, and the last one is statistics and probability containing chapter number 14 and 15 carries 12 marks. In total it is of 80 marks. Let's check how this 80 marks are divided into different forms of questions. So remember that your question paper will be containing 4 different forms of questions, including multiple choice questions, very short answer type questions, short answer type questions and long answer type questions, where each multiple choice question will carry 1 marks and such 10 questions will be there. So 1 tens are 10 marks are given to multiple choice questions. Similarly, each very short answer type question will carry 2 marks and such 5 questions will be there. So 2 5s are 10 marks are given to very short answer type questions. Next to it, each short answer type question will carry 3 marks and such 10 questions will be there. So 3 tens are 30 marks are given to short answer type questions. And at last, each long answer type question will carry 6 marks and such 5 questions will be there. So in total 6 5 the 30 marks are given to long answer type questions. And remember that in ideal situation your question paper will be of maximum marks 80 and of time duration 3 hours, and remaining 20 marks depends on your internal assessment. That's it. So after discussing the weightage given to different units of class 9th mathematics, let's start with chapter number 1, number system. Before starting with this chapter, you must revise all different types of numbers you have studied in previous classes, including natural numbers, whole numbers and integers. And thereafter you will study rational numbers and irrational numbers, which are the main topics of this chapter. So let's start with natural number. So natural numbers are those which are used for counting purpose. And this set of natural numbers is represented by capital letter N. And natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. When all these natural numbers are included with the digit 0, so a new set of number gets formed called whole numbers. And this set of whole numbers is represented by the capital letter W. So whole numbers include 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and so on. Thereafter, integers. So when whole numbers are included with negative of natural numbers, so a new set of number gets formed called integers. So when all these whole numbers are included with negative of natural numbers like -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, and so on. So this forms a new set of number called integers, and set of integers represented by the capital letter Z. After natural numbers, whole numbers, and integers, next we have to discuss rational numbers and irrational numbers mainly. So rational numbers are those numbers which can be better expressed in the form of P upon Q. In the form of P upon Q, where P and Q both are integers, but that Q is non-zero. And numbers which could not be expressed in the form of P upon Q are called irrational numbers. So all these natural numbers, whole numbers, integers, rational numbers, and irrational numbers make real numbers possible. From this diagram, you may observe that all natural numbers are whole numbers, but all whole numbers need not to be natural numbers. Like 0, it is a whole number but not natural number. Similarly, all natural numbers and whole numbers are integers, but all integers need not to be neither whole numbers nor natural numbers. Like -1, -2, -3, -4, -5, -6, these all are integers, but neither whole numbers nor natural numbers. Similarly, all natural numbers, whole numbers, and integers are rational numbers, but all rational numbers need not to be natural numbers, whole numbers, or integers. For example, 1 upon 2. This is a rational number, but it is neither natural number nor whole number and not an integer as well. Whereas this irrational number belongs to a different class under real numbers. In previous classes, you have studied that how to locate natural number, whole number, and integers on a straight line, which is better known as a real number line. On this real number line, just at mid of it, 0 is there, and as we go to the right of it, positive numbers are located, and to the left of it, negative numbers are located, like +1, +2, +3, +4, +5, +6, and so on up to +infinity. Similarly, to the left of it, we have -1, -2, -3, -4, -5, -6, and this goes up to -infinity. Along with this, you have studied that how a rational number could be located on this real number line. So let's check how this rational number 1 upon 2 could be located on this real number line. This time, this rational number is of proper type, whose value is 0.5. So It is more than 0 but less than 1. That's why this half or 1 by 2 will be lying between 0 and 1. So in order to locate this rational number, we divide that difference between 0 and 1 into two equal parts. For that purpose, we locate a point just in mid of 0 and 1. And this is the required position where the rational number 1 upon 2 gets located. But in this chapter, we have to discuss how to locate an irrational number on a real number line. But before of this, you have to study that how to insert a given number of rationals between two given rational numbers. So let's start with insertion of rational numbers between two given rational numbers. For that purpose, we have taken a question in which we have to insert 5 rational numbers between 1 and 2. This time we have two different methods to do so. So let's start with method number 1, which is better known as average method as well. Let's locate both the rational numbers on real number line. And this time you may observe that that's the position which is representing a rational number lying just in mid of 1 and 2, and this rational number which is lying just in mid of 1 and 2 could be better calculated as average of both 1 and 2. So it becomes 1 plus 2 upon 2. It means 3 by 2. So that's the first rational number we found between 1 and 2. Next to it, in the same manner, we find the rational number lying just in mid of 1 and 3 by 2 and just in between of 2 and 3 by 2. So these two rational numbers you may find as average of 1 and 3 by 2 and 2 and 3 by 2. So it becomes 2 ones are 2 plus 3, 5 upon 2 twos are 4. So the rational number just in mid of 1 and 3 by 2 becomes 5 by 4. Similarly, 2 twos are 4 plus 3, 7 upon 2 twos are 4. So this 7 upon 4 is the rational number lying just in mid of 3 by 2 and 2. So in total we got 3 rational numbers lying between 1 and 2. So these 3 rational numbers are 3 by 2, 5 by 4 and 7 by 4. Still we have to find two more rational numbers between 1 and 2. So in the same manner, you may find remaining two rational numbers, which could be the average of 1 and 5 by 4, average of 5 by 4 and 3 by 2, average of 3 by 2 and 7 by 4, and the average of 7 by 4 and 2. So any two you have to calculate, any two, not all four, any two you have to calculate. So try to find remaining two rational numbers in the same manner yourself. Let's start with method number 2. In method number 2, again we locate both the rationals 1 and 2 on real number lines and we start dividing this difference between 1 and 2 into 5 plus 1. It means 6 equal parts. So as if 5 rational numbers are located between 1 and 2, so these 5 rational numbers will be dividing this difference between 1 and 2 into 1, 2, 3, 4, 5 and 6 equal parts. So in order to find the rational number just after 1, we have to add something to 1. So let's calculate this something. This something is known as difference, and this difference you may calculate while dividing the difference between 1 and 2 into 1, 2, 3, 4, 5, 6. 5 plus 1, 6 equal parts. So it is 2 minus 1, 1 upon 5 plus 1, 6. So that difference D we have 1 upon 6. Now in order to have first rational number after 1, we add this D to 1. So it becomes 1 plus 1 by 6 equals to 6 ones are 6 plus 1, 7 upon 6. So that's the rational number, first rational number between 1 and 2. Similarly, after 7 by 6, to achieve this rational number, we add D to 7 by 6. So it is 7 by 6 plus 1 by 6 equals to 7 plus 1, 8 by 6, or in simplified form 4 upon 3. For the same you may calculate if 2D, D and D, 2D are added, 2D is added to 1. This you may calculate as 1 plus 2 D also. 1 plus 1 by 3. So it is 3 ones are 3 plus 1, 4 by 3. So that's the second rational number between 1 and 2. Between 1 and 2. Let's check the next rational number after 4 by 3. This you may calculate if D is added to 4 by 3 or D, D, D. It means 3D is added to 1. Either 1 by 6 is added to 4 by 3. So it is 9 by 6, or in simplified form 3 by 2, or the same you could find if 3D is added to 1. So this equals to 2 ones are 2 plus 1, 3 by 2. So 3 by 2 is the third rational number between 1 and 2. So in the same manner, you can find the rational number after 3 by 2. Let's add d to 3 by 2 or 1, 2, 3, 4. 4d to 1. So the next rational number you may calculate either adding 1 by 6 to 3 by 2 or by adding 4d to 1. 3 ones are 3 plus 2 ones are 2, so it is 5 by 3. So this 5 by 3 is the fourth rational number between 1 and 2. In the same manner, try to find this fifth rational number yourself. And remember that as there may lie infinite rational numbers between two given rational numbers, that's why the different rational numbers calculated using either of these two methods need not to be equal to each other. They could be different from each other as well, but the necessity is that all the rational numbers calculated must lie between both the given rational numbers exactly. That's it.